All right, hello everybody, this is Miss Pi. I'm going to go over how to do projectile motion problems. All right, so if we have an object like a ball or a rocket is kicked, thrown, or launched with initial velocity v at an angle of theta from the horizontal. Okay, then its horizontal and vertical displacement can be modeled by the parametric equations as follows. Okay, I'll show you the formulas first and then I'll explain how we're getting them. So your x formula would be your magnitude times cosine theta, and theta is in degrees. I'm thinking, yeah, for all of the problems that we're going to look at in this unit, your theta is going to be in degrees. And then times t, and remember our t value is typically your time. And then for the y variable, or the y formula, same kind of thing, except we're using sine, okay? So why are we using sine and cosine? Well, let's think back about the vectors and magnitude and our unit circle when we did our x's and y values. So remember, if we have an angle theta here, then our horizontal unit of measurement here would be found by the magnitude times cosine theta, okay? And your y value is magnitude times sine theta. Okay, so this is kind of we got this from our vector unit when we were doing that early this year. Okay, so this is just a rehash of those formulas, and we're using them in parametric functions. Okay, now the problem is that if an object goes up, it has to come down. Well, what makes it come down? Most of you remember physics and remember that gravity is going to pull whatever object is going up in the air, it's also going to pull it down. So we've got to change that formula a little bit, and it depends on our units of measurement. So if our units of measurement are in feet per second, then we are going to use these two formulas here. Now your x formulas are going to be the same. It's just your magnitude times cosine theta times time. And the x formula, all that does is tells you the horizontal location. Okay, and then the y formula, if we're in feet per second, the effective gravity is going to be, you're just subtracting by 16 times t squared. Okay, those of you in physics, you'll remember that the effective gravity is 32 feet per second, and because we're going up and then coming down, we're going to divide that 32 by 2. I don't remember all the physics behind it, so those of you that remember all that physics stuff, feel free to explain it all in class tomorrow. If you guys don't remember, don't sweat it. You don't really need to remember all of it. You just need to know that the negative 16 t squared, that's from the effective gravity on the vertical displacement, okay? Now, so what happens if you are in meters per second instead of feet per second? Well, meters is going to be negative 4.9 times t squared, okay? Again, it's just your gravity in meter measurements instead of feet measurements, okay? So these are fairly simple formulas, not too complicated. Just you need to remember if it's in meters, it's 4.9. If it's in feet, it's 16. All right, let's look at something else. On the bottom of your page in your notes, you have this information here. Okay, so when you are in feet and something is launched from the ground level, then you have this formula. Fairly simple. You can write it down on your paper. But what happens if you're not at ground level? Let's say you're on top of a house or on top of a building, or maybe you're standing on somebody's shoulders and you're throwing a football, whatever, okay? If there's any other height besides ground level, then you're going to add that initial height to your y formula. So instead of just being like this, your formula, you're going to add whatever that initial height is. So hopefully these are pretty simple formulas. You're going to use your parametric functions as usual, but now we're applying the effective gravity and initial height. So let's look at one example. Now this is not in your notes, and trying to think. Yeah, it's not in your notes, but the very last page of your notes, you have like half a page that's blank. You might want to jot down these notes in this process on how we did this, okay? So let's say we're hitting a golf ball. And the first time you hit the golf ball, the velocity is 100 feet per second, and the angle is 20 degrees. So to fill out your formulas, it would look like this. You do the velocity times the cosine of the angle times t, and velocity of 100 times sine of the angle times t, minus your 16 t squared, and we're using 16 because it's the feet here, okay? So that's what we plug in the formula. Now, we want to find the maximum height, we want to find the horizontal range, and the flight time. So we know that we can plug it into the Inspire calculators, and if you graph that, this is what, this is our formula. All I did is I graphed it, okay? So there it is. And most of you know that if you are looking for your maximum point up here, all you have to do is analyze your graph. So you go to Menu, Analyze Graph, and click on Maximum. Well, and it asks us, what graph are we looking at? Well, I want that graph. Wait, that graph. No? Okay, that graph. Is anything happening? Notice I'm clicking on it, but nothing's happening. Well, the reason why is because your calculator's not set up to analyze your parametric graphs. Sorry. So guess what? Cannot use this whole analyze graph program. Can't use it on this calculator at all. So we don't need this. You got to solve it algebraically, okay? There are steps to finding this information out. If you want to know the horizontal range, you want to know how far is it going to be from this initial point here to when it hits the ground again. Okay, so way over here. Well, if you look, your y value is going to be 0 here, and it's also going to be 0 here. So to find your horizontal range, or how far it's traveling horizontally, you're going to plug in, you're going to take your y formula, okay? I'm just taking my y formula, I set it up, and then I'm going to set it equal to 0. Notice I have a 0 here. That's all I did, okay? As I just made y equal to 0, and I'm solving for t. All right, so now I solve for t, and I simplify as much as I can. Notice I'm factoring out my t's. I have a t here and a t squared here, so I factor out a t. So now I know that t can equal 0, or t, or 0 equals all of this mess. Well, this part is easy. T can equal 0. Easy, easy, easy. But now I need to solve for this. I'm going to subtract by 100 divided by, 100 times sine 20 degrees. And then I need to divide by negative 16. So because I have two negatives, it gives me a positive. So then my t can equal this, and it can also equal 0. Well, when t is 0, my x is 0, so I don't care about this, but I am interested in this portion. Okay, I want to know what does all of this equal. I'm just going to plug it into my calculator, and I find that t is approximately 2.13763. Okay, when I'm showing my work on my paper, I'm going to use this value, but when I calculate it out on my calculator, I'm not going to type in 2.14 or whatever, because that's a rounded answer. I want to be as accurate as possible, so I'll actually type in this. But for space, just type in the 2.13. All right, so that's my time when y is 0 for this point here. So because my time is 2.13 seconds and 2.14, I guess, I can say that my flight time would be 2.14 seconds. Now I'm going to take that flight time, plug it in to my x formula for my t value, and I'm going to just replace that t value with this answer, okay? And all I do is plug everything into the calculator, and I get the x is approximately 200 and 200.8, well, let's say 200.9 feet. Okay, you can round it if you want to. Notice I did not round it. I wasn't too worried about it. But my horizontal range, the distance from here to here, is approximately 200 feet. Okay, so I have my horizontal range. I have my flight time. Now I want to find my maximum height. Okay, the process, let me line that up, sorry. Process, I already know my flight time is 2.13. Well, for my maximum height, it's right here. And those of you that remember parabolas, you know that halfway between your starting and the stopping point on your parabola is your maximum height. So you're going to take your t value here, divide it by 2. When you do that, you get approximately 1.07, let's say. Now let's plug this in into my y equation, replacing my t with 1.07, excuse me. And I just plug it all into my calculator, and I find out that my y value, my maximum height, is approximately 18 feet, and that gives me my maximum height, okay? So there were 3 different things we were looking for, okay? And I actually did this in a different order. But first, I set y equal to 0, and I solve for t. And with these, you're always going to get 2 values for t. You will get t equals 0, and you will also get t equals some other number. It doesn't matter what the other number is, but you have to find that other number, okay? So right here, this is just some number, okay? We all know that t is going to start at ground level when t is 0. Sorry, x is going to be 0 when t is 0. We know that. We don't care about this. We want to know this value, okay? You're going to use this value to find your maximum height. You'll divide that n by 2, and then plug that in for the t's in the y equation to solve for y. That'll give you your maximum height. Guys, this information is in your notes. To find the horizontal range, the distance from when you start to go and then you hit the ground again. So the distance from here, this is your horizontal range, this distance right here. Okay, to get that, this time you do not have to divide n by 2. You just take your n value, plug it into the equation for x, into the x equation, and then solve for x, okay? Watch this video again if you need to. Make sure you understand how to find your maximum height, your horizontal range, and your flight time.